There we go. Okay, so we are going to quickly get support for our entity relation language in Eclipse. So this is the xtext enabled Eclipse, and we do a new an xtext project. Okay, and project name, whatever, we use a better name when you do it for real. Language has to have a unique name as well. Extension. Remember the extension, okay? You need to remember the name of the extension because you need it later. Because if you don't remember the name of your extension, then you can't write programs that have the right Eclipse support, because that's based on the extension. Like .java gives you Java, and in this case, it's going to be .entity-relation system, EIS. So, write it here. EIS. So if I forget it, then you can remind me. So EIS, and that's basically it. So, okay, now we get a small grammar. So this is almost like what you saw before. This is model. This is the name of our language, if you want. I'm just going to. So this is going. We want to call that an EIS system. This. So xtext has a bunch of convenient things. So in the small example here, there's just a bunch of things called greetings, which are sort of a silly example. We want, of course, a bunch of entity objects. Now, the plus equals here means an EIS system should have a number of, that's going to be an object. So it's going to be an object called EIS system, and that's going to have a field, which is a whole bunch of things that are entities. So I'm going to call that entities. Plus equals mean whenever you find an entity in the program, add it to this list. So this collect all, so this gives us names, the names that we're missing up here. What is the name of a relation to something else? We get that by writing the name, and then plus equals or equals. Plus equals for many, equals for one thing. So this builds the model. A model that has EIS system as a root object, and then a bunch of entity objects, which was kind of missing here, because here this was actually just one entity type, but of course we also had many of them. And we never had something pointing to all of them, but we need to have that here, because now we're doing it properly. Okay. So, an entity. So an entity has the keyword entity, like this. This is how I write in xtext. It gets color blue because right now it doesn't add anything. There's no information in it. But then I want a name, and that's going to be an ID. ID is predefined as something that would pass in Java as an identifier, which is convenient. Name is red. It is kind of magic. Name means this is the name of the object. So I can use that name other places in the program, and then I get a reference to that. So rather than getting my tree structure, I get a model with objects that point to objects. Let me show you what I mean. We have, like here, we have extends with a question mark, like I showed you before, and that should then be, extends should be then, this is called a parent, which is an ID. Okay? This just gives a name. It doesn't give a reference to another entity. If I want that, I write it like this. This means find the entity that has the name I wrote here and link to that. So I get the model with references between entity objects rather than just stupid names that I have to resolve myself. Okay, so name, which is the name of the entity, and that's the name I can refer to implicitly here from another entity, of course. Actually, I can also write entity person extends person. That's legal in my language, so I have to check for that somehow else. Then an open brace, like this. And then I want a number of members. So members plus equals member star, and a close brace. Okay, there's no member yet, so I define that. A member is either a property or a relation. Okay, property A property is something that starts with the keyword property, like before. And then there's a name, which is an ID, the colon, and then the type, which is, well, I could just make a string like before. Then I can write anything here. Alternatively, I could also say that, or maybe I have to specify what the types are. So, this is really annoying if you watch the screencast, but I would write type int here, which makes int a legal name to use in my entity relation system. So this means I define all names of all types. So that would be, well, how do we do that? Well, we just say that we have types that are defined as type, like this. So first types and then entities. A type is something that has the keyword type, and then name, which is an ID. Okay, so now I can write type is just a type. So that's something I declared with the keyword type. So I can write int and string and so on, and those will be names that are known to it. And that's it. That's all I wanted for my property. If I wanted semicolons at the end of lines, I could put that here, but I don't really need that. If you want semicolons, if that makes you feel good and comfortable, then put that, but I'm okay with not having them. Relation. So relation has the keyword relation. It has a name, which is an ID, a colon, a type, which is now an entity, like this. And then we have, there might be something for an inverse, right? So then we have the keyword in, oh, there might also be the multiplicity. Yeah, that's, oh, let's do that first. So I think I put multiplicity over here. So now we want to know, was there a star or not? So the way to do that in xtext, this is all, xtext is really well documented, okay? This is well described everywhere. But question mark equals means it's a boolean. If you find a star, then it's true, otherwise it's false. Okay, and now, so that's the entity, and then we might have something for an inverse. Then we have the keyword inverse, and then there's inverse multiple, let's call it that, multiple, if there's a star. And then there's a name, inverse name, it's an ID. So here there's actually kind of a limitation of xtext, which is that, well, the inverse name, what are legal inverse names? Well, there should actually, the only legal inverse name is the one that, actually no, in this case, no, that's fine. Actually, I can write any name here because I don't write the corresponding field in the other type. And but you can only do limited things here. If I wanted to make sure that the same name was used for properties in matching classes, a parser can't do that. You have to check that in your program afterwards. But that's it. So I think this is a first shot at our specification. So this is enough information to both have the parser and the metamodel, because we now have also what are types that we want to use to build the metamodel, and the relation. This is a reference to another object, and the name is just a text string. Okay, so actually, so the xtext is in here on the source, my.dsl.xtext, and then there's something called an MWE. That's a workflow specification language, because to go from the xtext specification to all of those things we magically want, you have to call a lot of different tools. There's a lot of generators that have to be called. So xtext does that automatically. You can either run the workflow or do run as generate xtext artifacts. So I'm just doing that one here. Now we get a question here, do we want to download it? You can, of course, install it. There's also a way to install it once and for all. But right now, because I haven't done that, and you can figure out how to do that, then it just downloads it like this, hopefully. Internally it uses the parser generator called Antler. So this is something that actually creates the parser. Xtext doesn't do that automatically, or in itself. It uses actually another parser generator for it, because Antler is it's a good parser generator and so on. Once the parser generator runs, you can get errors from it. We will talk about that next time. For example, if I hadn't put relation and property here, I would get a weird error from the parser generator. Because just like you didn't know what to do in the program here, is it a relation or a property, the parser doesn't know either if you don't put in these keywords with the kind of parser that Antler generates for you. Now, there are other parsers that might be different, but in this case you will get an error. We will look at those kinds of errors next time. But here it was happy. You have to look at the output down here. Were there errors? If there were errors, then that means that there was an error. There was a problem. So that might mean that things didn't work out for you. But in this case, there were no errors. So then we do run as on the project as Eclipse application. This launches a new Eclipse, which has support for our language. So here I was playing a bit with it yesterday. So let's make a, I'll just give it a little while. That's fine. There we go. So new, actually a Java project is convenient, but because that has appropriate support for Java and so on. And then it's so software application test, and you don't need anything special here. Okay, and now we create a new. So you don't automatically get like a new whatever it was you made here. You can add that to the Eclipse as well, but that doesn't go in by default. So we create a new file. What is the name of the file? The name is university dot. And now, what was the name of the extension? Yeah. Now, you can also find that inside one of the configuration files, but it's just that many times, especially when I had to show it, I got to this point and then I completely forgot the extension because there's so many other things happening. So, writing it down. Okay. Now it asks, oh, do you want this to be magically xtextified? Then you answer yes. Okay. And now, well, now we have a text editor. But it does know something about our language. So we could write entity, right? It gets highlighted, so entity person, like this. A person has a name which is a string. That wasn't actually the syntax we wanted, or that we specified. We specified that you had to put property first. So property name is a string. String is not identified. It knows it's supposed to be a type, but we haven't defined it. Okay, so let's do that. Type string. Okay, that's good. And we also have click to jump to definition like you used to, because of course it has the model behind us. And then there's and let's make a type int. Then property age, which is an int. Okay. And then there's entity student extends person. And this has a property ID, which is an int. And then we have the relation enrolled to a course, to many courses like this. And of course we're missing our entity course, which has a course has a title, which is a string, and that's a property. Okay. And we have an inverse, which is follows like this. Okay. So I actually didn't make any mistakes in my BNF. Done this example a couple of times before. If you make mistakes, then you have to quit the Eclipse that you launched, go back and change it. So let's make a change to the grammar here. Let's try an experiment here. Let's say that I don't want to have the property keyword. Okay. Let's see if I'm not sure if I think that should work. So either relation, that's a big thing we use. We write a relation in front of it, but just properties, we just write them without anything. Because it's kind of annoying to write property every time. Okay. So let's. Here we have xtext, and then you can see there's all kinds of things that are being generated here, and there's all. I mean, these here all contains all kinds of stuff that has been generated for you. Ah, interesting. Okay, here. So this is our metamodel in here. See the ER system, the member, property, relation, type, and so on. They look a bit funny actually when you look at them more closely, because they're part of the Eclipse internal metamodel, which allows you to model any kinds of objects. So an E object, well, we have get name, set name, get parent, set parent, and get members. So this is an interface, and we automatically get getters and setters. And that's actually all it does, because this is just for representing the data in the metamodel. You can't really compute on it. You can get information from it, but you don't have behaviors in it. So anyway, we modified our xtext grammar. So we have to rerun generate artifacts. Okay, and we're done. Now this went well because our grammar, our parser can still figure out which is which. If there's the keyword relation, then it's a relation, otherwise it's a property. So it's easy to figure out. If I remove relation as well, let's just try to do that. Okay? Like this is a legal grammar here. We do run as xtext artifacts. So here you get, actually you get them as warnings, which is kind of funny. Okay, so this one can match multiple alternatives, and so it disabled them. So probably it's probably deciding to not include those in our grammar, which is kind of bad. So let's put relation back in here. So that's why it's important that you look at what it generates down here. Run as generate artifacts. How are we doing on time?
You're doing good.
How much time do we have left of the class? Sorry?
6 minutes.
6 minutes, okay, good. So now we have it here. Now again, I need to relaunch my Eclipse application on the project. We are not going to do code generation today. Code generation is unfortunately more complicated. We have BNF, which is wonderful for parsing. There is no equivalent for code generation.
So you have to make it your own.
You have to write it in a programming language. And since we're in Eclipse, you would have to use Java, which I know many of you hate. So did the people who made this, because they were like, oh, we have xtext, which is good for making languages, and we hate using Java for writing our code generators. So let's make a really good language for making code generators. That's a language they call extend, which we'll look at next time. It's sort of similar to Java, but for the C# people, it has the properties that you want. It also has things that you don't find in any of the languages, something called multi-dispatching, which is a really powerful feature for writing this. So there are things you don't find in those other languages. Okay, now here's something interesting. We changed our grammar, but everything looks fine. Except that these are not highlighted anymore. But we should get parse errors, right? So the thing is, it doesn't reparse until you modify it. So when I insert a space now it complains. Like, there are two things in front of this. And it thinks that this one is something extra because it doesn't know the property. Property is no longer special. So let's get rid of the property. Oh, hold on. Property, property, and property. Okay. So that's how I go and modify it, regenerate, relaunch the Eclipse, and now I have my new parser. It's also in behind, it's generating the corresponding model instance. We're not going to look at that today. And but as you could see, we do have, so where were they? They were in here. We do have the corresponding types here for the metamodel that is implemented for us, and as soon as we type this, we have a metamodel instance. Now what we're going to do next, and we're going to look at it next time, is how to write a code generator. That code generator is going to look at the corresponding metamodel, so that's going to be a list of entities, and then it's going to generate a Java class for each of them. If you're curious, then you can go ahead and look at the xtext tutorial, which goes all the way with this, with their own entity example, which is a bit more advanced in some ways than what I have here. But we will also look at that next time. And I think that's it. So any questions?
No.
Interesting.